At least me, yes.
Okay, great.
Yes.
Wonderful. So good afternoon, everybody. Welcome at this event. My name is Hans Engels. I'm the head of unit for bioeconomy, chemicals and cosmetics, which is a focal point for bioeconomy in the Director General for Internal Market Industry Entrepreneurships and SME in the European Commission. As the chair of the first session, I'm happy to see you all in this third bioethics event of the 8th Raw Materials Week. According to our technical team, we are around 250 people connected from Europe, the United States, Canada, South Africa, and Korea. And we're all excited to hear about the newest development in the forest-based bioeconomy. Please note that the event is recorded and it will be available on the internet after the event. If you have questions, I'm sure you have questions and comments, you can send these questions and comments via Slido to us. Now, it is my great pleasure to introduce our Deputy Director General, that's Maret Rutte. She's Deputy Director General of the Director General for Internal Market Industry and Entrepreneurships and SMEs of the European Commission. She will give the opening speech. Maret Rutte is part of the top management for industrial policy for Europe. And her particular attention goes to decarbonization of industries and transition to new, greener and digital production modes, resilience of supply chains, promotion of investments and protection of intellectual property rights. Maret is a member of the InvestEU Steering Board, the steering committee of the European Innovation Council and SMEs Executive Agency, and she's also a member of the EU IPO. Maret has a lot of experience in this field. Between 2009 and 2019, she worked as a senior management in the research and innovation field of the European Commission after starting as director for entrepreneurship and SMEs here in the European Commission. And Maret also in her home country served as a deputy governor of the Bank of Estonia and as CEO of Credex, the Estonian business and export financing body. Maret is also exceptionally knowledgeable about the bioeconomy issues in the Commission because it's not only due to her current position now, but also due to years of senior management for bioeconomy in the Director General for Research and Innovation. So Maret, welcome here. The floor is yours.
Thank you a lot, Hans. This was really a long introduction than me, but thanks a lot. Indeed, today it is a bit like coming back to family party, if you wish. During the time when I worked in the Research and Innovation Department in the European Commission, I indeed had the pleasure to lead the work on creating this new European bioeconomy strategy a few years ago, which, among other things, has brought, I believe, many good companies around bioeconomy as a topic, as a strategy, and also to our joint undertaking, which is a good platform for collaboration. So on this background, it's really a great pleasure to open today the third annual Biotics event in the European Raw Materials Week. The theme of this year's event, Bio-based Solutions for the Green and Digital Transition, is of course at the heart of the Green Deal goal for climate neutral and circular products, as we all realize. And of course, we say the goal is to have them by 2050, but we will not wait until 2050. We would very much like to see this type of products more and more on our market already as we go, and certainly more than we have today already by 2030. We have recently proposed the so-called Fit for 55 package. As you know, this is the implementation package for the Green Deal. And it is called Fit for 55 because the aim is to reduce greenhouse gas emissions by 55% by the year 2030 if we compare the level of 1990. And this is actually a very far-reaching integrated regulatory framework which is there to deliver on the climate law targets. And it will also soon be complemented by further proposals, for example, on deforestation, also on sustainable products, and on restoring carbon cycles. So, of course, the climate change forces us to think very much and to focus on carbon footprint, carbon removal capacity, also circularity of the products, cascade use of the products. And we have now this new sense of urgency for good, long-lasting, sustainable choices. So as part of the updated EU industry strategy, which we have indeed published this year in May, we foresee bio-based solutions as one of the ways, so also contributing to the co-creation of these scenarios or pathways towards this new sustainable and more resilient future. We are working on something we call transition pathways. So transition pathways is a way, together with industry, together with member states, to generate more clarity how in reality we deliver on these climate targets. And we are in the process of working very closely with energy intensive industries, construction, textiles, also the mobility sector, and in fact, tourism as well. So with all these broad sectors, we are reaching out to you to see how to turn the climate targets into reality, what it takes, what kind of scenarios, what kind of tools, and what investments, of course, as well. We see that forest-based industries form unique, mainly Europe-based value chains, provide close to 10% of EU value added. Well, employment is in the magnitude of 3 million in different EU regions. So it's really an important sector in Europe. And we also see that in these value chains, wood changes its form many times, from timber logs to furniture to textile, and even vanillin can be a product. So its various forms are parts of the infrastructures of our society. The wood is used to various industrial solutions. It forms a very important part in our living environment and in our everyday consumer choices. Simultaneously, it is also pivotal that the industrial sectors depending on sustainable forests continue to develop cutting-edge, innovative, circular products and processes. So this cascading use and the circularity and recuperation of the wood is something that should be brought even more to the focus than it has been perhaps so far. So in this event, we will hear more about the emerging breakthrough innovations and developments and about their challenges and opportunities in the Green Deal Europe. Operating within planetary boundaries will require more resource-efficient bioprocessing in the European Union. Therefore, key players will present their leverage of disruptive solutions now in 2030 and also with a view to 2050. And we will brainstorm with you, so in interactive way, hopefully, about means to make these solutions really something that can be taken up by many in the single market in Europe, as well as on global markets. All of this is to provide you with inspiration on how climate neutral, circular, bio-based products remove and store carbon, while at the same time substituting fossil-based products. And of course, besides of the substitution, we also hope that other pollutants would also be less, so the emission would be less. So ladies and gentlemen, this biotics event today is divided to 2 sessions, and at the end there will be also a panel discussion with core players in the bio-based industry value networks. The first session on circular bio-based industries, the global champions for climate neutrality. We will have again Hans Ingels, whom you already saw, our head of unit in DG GROW, responsible for bioeconomy and chemicals. So he will be chairing the session, and there we will, as the name already says, look into how these various excellent materials can be upcycled and what kind of products really woody biomass residues could provide. The second session on circular woody biomass-based value networks. This second session will be chaired by Secretary General of Forest-Based Sector Technology Platform, Dr. Johan Elmnert, and it will showcase how diverse woody biomass-based products enable building good-looking carbon storages, well, even in places such as center of Munich, and how grasping of the digitalization will help ensure better functioning of value chains. And the event then will lead to a panel discussion on disruptive solutions from circular woody biomass. This will be chaired by Mr. Peter Verheim from DG Research and Innovation. And Peter is also the guardian of the EU bioeconomy strategy nowadays. And of course, this will be also an occasion to hear how the bioeconomy strategy is doing nowadays. And there is a review report planned, I believe, next summer. So you will be in good hands during the next 2 hours. I hope you will come up with many good ideas how the bioeconomy with its forest-based industries could further spur its central role in providing green, digital and resilient solutions for Europe. And this is, of course, solutions for now as well as 2030 and 2050. I wish you a very fruitful conference today. All the best. Thank you.
Thank you very much for your very inspirational words, Maret. Indeed, we need broader engagement of industry stakeholders and citizens here. And before turning to the political aspects, I will say a few words about this first session, which I'm honored to chair, about the circular bio-based industries in the global, as global champions for climate neutrality. This heading is inspired by the European Green Deal and our European habit to set the bar very high in general, and even higher within the circular bio-based industries. Forest-based industries are an excellent example here. They started already in 1800, yes, in 1800, and they had to make almost everything out of wood, as fossil-based resources were not lavishly available. And they were pretty innovative at that time. For example, in 1940, a product stream, one company lists 60 different products from lumber to advanced organic chemicals. And those companies were global champions in their products, but not necessarily in environmental friendliness. But today, the One Planet principle asks for a new competitive edge from climate neutral, zero pollution, and high performance circular bio-based products as a matter of strategic importance. And that innovation plays a vital role. And to live up to these requirements, a lot needs to change, and a lot is already changing. So in this session, after my talk, I will be very honored to welcome two keynote speakers and two experts in the area, as Professor Rojas and Professor Caillou. And so they will enlighten you on that. So, but I will first turn to the political aspects. Indeed, and if you have any questions during the entire session, then please ask your questions in the chat in Slido. Now, I'm very honored to start the session with some insights to the political agenda of to the political aspects of our agenda today. I don't have to explain the European Green Deal. It's the EU's new growth strategy. And it aims to transform the EU into a cleaner, fairer, and more prosperous society in cities and in rural areas. For Europe's ambition to deliver the Green Deal, the industrial strategy plays a vital role. And achieving a climate neutral circular economy requires the full mobilization of industry. It takes 25 years, a full generation, to transform an industrial sector and all its value chains. To be ready in 2015, actions need to be taken already now. Our ambition is to reduce greenhouse emissions by 55% by 2030 and to achieve climate neutral circular products as a norm by 2050. The bioeconomy is vital for this to happen. But these are not only the Green Deal targets relevant to bio-based industries. The zero pollution actions strive for reduced pollution levels, which our planet can cope. Bio-based circular products are the key facilitators for this. And only with drastic efficiency boosts, this will become a success story. So we need to strengthen forest resilience to climate change, protect biodiversity, and nurture stronger valuing of ecosystems. The EU bioeconomy strategy is spurring actions with broad-scale engagement of member states, industrial operators, NGOs, and citizens. Actually, where we are today is mainly thanks to numerous bioeconomy strategy actions since 2012 in the EU. However, there's a big but here. During the last 10 years, the share of the bio-based industries in the EU 27 GDP has increased less than 1 per mil. This means that there is no strong enough shift away from fossil-based economy, although it ought to be drastically intensified. So today in this event, we will offer a nice reality check for forest-based industries. What radically new can be upcycled from residues? Where woody-based, biomass-based materials can enable the leap towards a bio-based economy away from the fossil-based one? How can structures and instruments in our society trigger big jump cards for the difference now and in the near future? And will Europe lead in the bioeconomy? So this year, the Commission updated its 2020 industrial strategy. Our policies have a greater ambition in making European industry more sustainable, greener, more competitive globally, and more resilient, while strengthening the EU industrial base. The use of bio-based feedstock, sustainably sourced from Europe, has high potential for future growth, reindustrialization regions, and also addressing societal challenges. I hope that, for instance, also the forthcoming textile strategy will greatly benefit from that. The key political question is how to make the transition towards the policy goals to happen. The political goals are very challenging. What are the risks, costs, scales needed, benefits, return of investments for greening? Still, they also offer numerous opportunities. New competitive edge with environmental friendliness, local feedstock without supply chain disruptions, continuously renewing knowledge base in the EU, aligned to zero pollution, and our values, how to foster our common good by living in balance with our nature. The transition pathways will address these kind of issues of the co-creation of the twin transition, the green and digital transition, together with member states, public authorities, industry, social partners, and all possible other stakeholders. Bio-based industries, including the forest-based ones, can make a significant contribution to the twin transition of energy-intensive industries, construction, textiles, and mobility ecosystems. And the Commission invites all stakeholders to work together and propose concrete actions, commitments, and investments to unleash this ecosystem's green and digital potential, while strengthening the resilience of its value chains. Emerging advanced technologies, for instance, nanotechnologies, biotechnology, membrane technologies, biogenetic carbon capture utilization for truly closed-loop biomaterials are part of the solutions. They will allow drastically more efficient processing of forest-based biomass with better yields and less energy and chemicals. And this applies to virgin and secondary materials, And it offers also new insights, especially how lignin from residues can be utilized for new bio-based materials and products. Ambitious policy goals aim at the benefit of our society, and operating within planetary boundaries asks for a very efficient use of raw materials. And for that, research and innovation are key. The Commission continues to support bioeconomy in its Horizon Europe research program and a public-private partnership on circular bio-based Europe. Let me conclude on my part on the political aspects. Ladies and gentlemen, the circular woody biomass-based products provide carbon storage and substitute fossil-based ones. They offer an acceleration of the twin transition of our industries and a significant contribution both to the 2030 targets and the climate neutrality by 2050. And I'm sure that this will reinforce our strategic autonomy and make European industry more competitive on the global market. Thank you for your attention. Now, let's also move at the more at our distinguished guests for the more technical aspects. Our first keynote speaker, and it's an honor to have him here, is Professor Orlando Rojas from the University of British Columbia, Canada. Professor Rojas is a real world citizen. He was born in Venezuela, studied in Spain, and then dived into research and innovation in the Northern Hemisphere, boreal forest-rich countries. It must be early in the morning for him. It's in the afternoon here in Europe. I guess that he had to get up at midnight or so for this. So, Professor Rojas, welcome here. Professor Rojas is a Finland Distinguished Professor, Canada Excellent Research Chair in Forest Bioproducts. If I have to read his entire CV, I will be busy until 3 o'clock, and that's not the purpose, but I'll give you a short overview of all his achievements. He also honorific affiliations with 7 universities around the globe, in Asia, Europe, North America, South America. Professor Rojas is also elected fellow of the American Chemical Society, the Finnish Academy of Science and Letters, and he also achieved important impact in his capacity as former PI of the largest flagship program in Finland, the FinCERES cluster between VTT and Aalto University, whose mission is to advance the future forest-based materials economy. Now he's working in Canada, and among his current roles in Canada, he's scientific director of the Bioproducts Institute, which affiliates approximately 40 professors while holding professor appointments with the departments of chemical and biological engineering, chemistry, and wood science. Professor Rojas is also a recipient of the 2018 Anselm Payne Awards, the highest recognition in the area of cellulose and renewable materials. And he's been distinguished by the TAPI with the Renewable Nanotechnology Award. So it's clear that Professor Rojas is a very established figure in academia and industry. And this is best exemplified by his recent initiative, the foundation of the Boreal Alliance between Canada, Finland, and Sweden, which is the largest research cluster in forest products, creating cross-disciplinary and cross-border solutions. Now, good morning, Orlando. It's good afternoon for us. So I hope that it's warmer in British Columbia than here in Brussels, where it's fairly chilly. So without further ado, the floor is yours.
Thank you very much, Hans. And yeah, it's very early in the morning and a rainy day here in Vancouver. I'm very happy, very excited to join this webinar. And what I have prepared is something related to the use of wood resources in next generation materials. And in the bottom, you can see a QR code to link with our website for more information. If we go next, what I want to say here is that really the next material revolution will start with the forest. And as was indicated by Hans, and I think it's very clear that we are going back to the future, as the movie said. I think we need to go back to the forest. Next. And when I say forest, of course, I mean the idea of using the natural assets that we find in plants, in biotic sources, including trees. And this photo I took in Louisiana many years ago, and I always like to put it in context because I'm just marveled by the size and the beauty of trees around us. Now, of course, here we're talking about sustainable forest and the use of planted forest for the utilization of carbon storage, living organisms. And the living aspect I want to highlight in the next slide, in the sense that really in wood fibers, we have an untapped resource. I always want to say that this is a living organism that contains a very large degree of complexity as far as the composition and the functions. Think about a tree and all the functions that a tree has as an organism. It's interactive and it's multi-scale. So here we can imagine the possibility of harvesting such natural properties. And to me, the use of fibers as is going to be very important and very relevant in many material developments, given the properties that you can see in the bottom, from the strength, the chemical resistance, the biodegradability, and the sustainability in using the forest biomass. Next. What we have, however, in many countries, and this includes Canada, where I am at the moment, is the fact that in the forest, we have really this asset that has been utilized mainly by industry in large volumes. And you can appreciate here in this slide, in this figure here, this Sankey diagram, how the biomass is being used pretty much as a raw material for primary products that include lumber, bioenergy, and paper. And my main proposition here is that we can actually go to beyond what we're doing now and produce or add value to these sources. So if we can go to the next slide, I want to point this very nice image from the Finnish forest industries that really highlights a very important fact. Everything that you see in this image can be every material from buildings, from the windows in the buildings, from the textiles, the packaging materials, and everything, composites, including food. There are a lot of key aspects here, and every single of those can be produced actually from plant biomass. And if we go next, I want to go to the building inside my own apartment, and this is how it looks. And I want to really connect the idea here that in this room, again, everything that you see around can be produced from woody biomass. Everything from the masks that you see in the front to the packaging materials, the textiles, the furniture, the walls, as well as the windows can be produced from cellulose biomass. Next. The challenge is then how to go in this triangle from bottom up, meaning that really we need to start to think about product value and less about biomass input volume. And I take this image from the Ministry of Forestry, Lands and Natural Resources here in British Columbia to settle this idea that is very clear and I think we need to take and embrace. And when I talk to the officials, I think we are hungry really to have a demonstration, prototypes of many of these applications that I will talk about, so that there will be a domino effect in such a way that we start to adopt the carbon, the live carbon from forest biomass and residuals, as opposed to the dead carbon that comes from petroleum resources that has no function, has no complexity, and has no hierarchy, which is quite different than the type of carbon that is enclosed in the fibers that we found in woody and non-woody biomass. Next slide. Hence, we need to think about the plans. And of course, here is very important what the European Union have discussed about the key enabling technologies for the future bioeconomy. And here in the left, you can read the main components and blocks. And one of those, the one in green, if we click next, will be very important and very relevant for what we do here in our research. And that will be advanced materials and nanotechnologies as a key enabling technology. And that includes, of course, production and accessing high-performance materials, smart, sustainable materials, nanomaterials, and the adoption of nanotechnologies and others. So this last point can be seen in the next slide, where we explain how wood is composed of, again, a very hierarchical structure that goes bottom up into what you see here, from wood to the cell wall of fibers, And then where we can extract cellulose nanofibers that are the building blocks in the cell wall of the fibers. And then together with the cellulose nanofibers, we can extract lignin, hemicelluloses, and also we can produce the so-called cellulose nanocrystals. All these are, of course, the products that are beyond the typical pulp and paper products and have become very relevant nowadays. So there is a lot of research around all these materials where, once again, we can extract the functionalities, the hierarchy, and the complexity of the material to produce new functions and new materials under the umbrella of the nanotechnology. If we next see in this slide, this is roughly what I'm proposing here. We have been working pretty much on top with the large lumber trunks of trees, but enclosing those materials, we have the possibility to fractionate what you see in the bottom that are also very high aspect ratio particles that we call nanocelluloses. And this is a typical tool for the nanotechnology of the future, where we can extract, again, these small components that are in the nanoscale, where there are functions that will emerge as we put everything together. So in the next slide, you will see this perhaps more clearly. What we have here is from trees, the possibility, again, of fractionating nanocelluloses, and that requires processing, that requires adding some energy, and we call this the refining process or the deconstruction process that you see in the blue line as we go from the fiber level to the nanoscale material that is, again, in the fiber, making the fiber. But as we do that, we can see that then in red, the line red, we are gaining value, we are gaining performance just because we utilize the power of nanotechnology. And it will take me a long time to discuss this in detail, but I hope that you get the picture that by fractionation of the fiber cell wall and by separation of the different components, we can achieve new functions that I will exemplify in the next slides. So if we go next. One example, of course, if we compare the case of timber for construction, it's very clear what you see here on the left, that an ideal use of wood is, of course, construction, building materials. This is a very good way to store carbon. And this is a building that is here in campus, is made from wood entirely. And it's a beautiful example of what can be achieved. And of course, this is nowadays very popular. But in the nanoscale, if we go next, you can see how the little nanoscale fibrils, nanocelluloses that we extract also from wood can be construction elements at different levels. And what I put here on the right is a case of emulsifying systems where the nanocelluloses act as a skin for oil droplets, stabilizing the so-called oil in water emulsions. And just to be more clear, those emulsions are very important, for instance, in food, in cosmetics, and many other applications that you see in the bottom. So it's using the same material, but with different angle, with different functionality, in this case, in the area of food and cosmetics and other products that are very important in our daily life. If we go to the next slide, an example that is emerging very interestingly about the use of directly wood is using wood for desalination and filtration. This is being demonstrated in a number of very recent publications where we can manipulate wood as is to produce this effect that you see in the upper left part of the slide, where wood can be used to transport water and then remove salt from seawater. And what we use is the inherent structure of wood. But if we go to the next image, the same applies to other materials that are based on nanocellulose. Here we're then talking about cellulose nanofibers that can be put together into membranes for advanced filtration and bioseparation. So a very interesting technology. In the next slide, another example of using wood as is after some given transformation is some very recent developments about making the so-called transparent wood that is very useful for light management. But at the nanoscale, if we go next, you can see how the same elements that are in wood, the nanocelluloses, can be arranged in a space to produce something that is called a structural color. And a structural color is a beautiful example of how the nanoscale properties of cellulose that is in wood can be utilized to replace dyes and pigments that generally are very toxic by just using something that is called a structural color. The way the nanoscale materials assemble in a space make light to be selectively reflected, producing the beautiful colors that you see in the bottom. And in this sense, there are many developments. If we go next, that have helped us to connect with society. An example here is the case of this garment in science fiction productions, where many of the elements here that are usually made, at least in this industry, are made from plastics. Here are made entirely from wood, and we don't use any pigment, but rather this natural light reflection that we find at the nanoscale. In the next slide, you can also see another aspect of using wood after given transformation, and this is for thermal management. So it is also demonstrated recently that wood is an ideal material for insulation purposes and to really control heat transfer. This is, of course, very well known since a long time ago, but the degree of advancement that we have achieved nowadays is really marvelous. At the nanoscale, likewise, if we go next, we will see how the nanocellulosic structures that I have discussed earlier can produce lightweight materials, as you see on the top right, that are called aerogels and cryogels. And these have been shown to be excellent insulators for instance, thermal insulation, and are known to be even better insulators than air as a material for heat transport. And likewise for sound insulation and packaging materials. So here the possibilities are really, really many. In the next slide, I also show something that is very close to us and to our daily life. And this is the idea of using wood for making the next generation textiles. And that will be discussed in the next talk. But I want to show in the next image on the right, how this can be also produced by using nanocellulose. And sorry that didn't run in the slides that have been shown, but nevertheless, the idea there was to produce filaments using nanocellulose to produce, again, the next generation textiles for our industry. In this slide that you are showing, that you are seeing now, you see the case also of super strong woody materials. This has been demonstrated in a very beautiful way. Taking wood simply and doing some lignin extraction, partial lignin extraction from lignin, applying a thermal treatment together with pressure, it is possible to produce materials that are super strong, stronger than metals, and show this capability that you see in the left bottom, that is, for instance, bulletproof materials. So super strong, lightweight materials. But that goes beyond such a structural application. We can also think on the right on many other multi-functionalities for the nanocellulose that we find in wood. And there I give some few examples that are already well demonstrated, producing films that are transparent, that are being used for solar cells, dye-sensitized solar cells, materials that can be used for energy harvesting, for instance, triboelectric generation and piezoelectricity, as well as producing electroactive materials. So really here, the opportunities are really staggering. In the next slide, just to close my intervention, and if we click again, is to connect a very important concept that we need to keep in mind, and is the fact that I have talked about the bioeconomy, but we also need to consider circularity. And I like this diagram that I show here now, this circle here, because I want to express here the very basic idea that in this circle of time scale, going from 0 to the 500 years, as you can read, what we do in green, in blue, is to take air, water, and sunlight from the atmospheric environment to produce the forest biomass in green. This, of course, takes years, especially in the boreal belt, in other fast-producing forests in the tropics, this happens very quickly. But the idea here is that we're storing CO2. And these carbon materials, biotic materials, can be used in construction, as you see in brown. And in construction, there is a possibility really to have a long carbon retention that is measured in the hundreds of years. But what is coming next is, in the lighter brown, is the use of construction, demolish wood to regenerate or recycle the material to produce other construction materials. And you can see here that the cycle then becomes very long life. In the smaller time scales that you see inside the circle, we have the paper production, paperboard and textiles. And of course, these are shorter time cycles, but are beautiful example of recycling materials. Paper in many countries are recycled and used to produce paper again, many cycles. So this shows the possibility for recycling these natural assets. And next slide shows how this connects with nanotechnologies. Is the fact that we are demonstrating how to take demolished materials, residual wood, that can be regenerated and put back together by a process that is called welding, fiber welding. So I don't have time to go in details, but what I want to incentivize here is a little bit of thinking how, by using nanotechnologies, it is possible for us to utilize woody biomass in the best possible way and use waste wood and regenerated wood, and also I would include other sources of residual wood, including those that are very high in cellulose components. In the next slide, I want to also pitch the idea that all that we're talking is not only a scientific exercise. There is a huge opportunity here for doing or making an impact. And here, this has been measured as the impact of substitution and transition. What is only a fraction of the fossil carbon is substituted, for instance, to make next generation plastics? Here, the opportunity is really very important, as you can read in the bottom. And this is recognized in the next slide, if we go next, by many different countries. And here I put the example that is very close to what we have done. This is a projection in Finland about how the value of production over time can evolve, and how the current forest products will continue its way, because they are very basic, very important in our lives. But the new value-added products, as those that you see on the right, really can make an impact that can be measured in percent points in GDP and increasing the total of exports. In the case of Finland, of course, it's very important. It represents 20% of the exports, but that can be really increased by adding value to the woody biomass in the examples that I have shown, but there are many more. So in the next slide, I close my intervention just to talk about the idea that the world needs to move towards a circular, renewable economy. And with this, the use of biomass is a great opportunity to meet climate and environmental goals. This is going beyond carbon storage. I think that from the environmental point of view, this is becoming more and more important. Forest resources really is an opportunity to make advanced bioproducts and to add value to biomass, including residuals. And the forest sector, of course, it can be very important to grow jobs in a sustainable business. And you can see a little bit more about the forest products as being safe, regenerative, renewable, sustainable, recyclable, biodegradable, and with very positive environmental impact. So no doubt that I think the future in the bioeconomy should consider the forest resource. And with that, I close in the next slide, where I want to pitch the idea that, the wood fibers is the future, and we are winning the environmental race. Thank you.
Thank you very much, Orlando. Thank you very much, Professor Rojas, for a very exciting presentation. If I would tell my children that there's something like transparent wood for light management, they will probably tell me to go and see a doctor or so. I'm always surprised by the innovation, and that you could make anything from woody biomass residues. So thank you very much indeed. Now we'll turn to Professor Maret Caillou. Maret is a professor of forest policy and economics at the Norwegian University of Life Sciences in Norway. She holds a PhD in management science from the Aalto University in Finland. And throughout her career, she has done policy-relevant economic research and consulting in the broad field of forest sector questions. For example, competition analysis, markets and trade, biodiversity conservation, wood-based energy, climate change mitigation, bioeconomy, and forest reference levels. Furthermore, Maret has also developed several modeling tools for such analysis. And before joining the Norwegian University of Life Sciences, Professor Caillou here, Maret also was working as a senior scientist in the Natural Resources Institute of Finland. Professor Caillou coordinates the Forest Sector Analysis Unit at the International Unit of Forest Research Organizations. So, Professor Caillou, Maret, the floor is entirely yours.
Thank you. Good afternoon, everybody. And it's an honor to have a presentation in this webinar. I'm going to focus on just one application of wood. There was so many exciting things in the previous presenters talk, but I'm talking about the wood-based textile fiber markets. The next, please. Can you scroll the whole slide down, because I cannot do it myself now. Okay. Yes, I see this only as a very small, so I need to have it from my own view. Okay, the outline of my talk has the following parts. I have a background, wood-based textile fiber consumption in a global textile fiber market, environmental benefits of wood-based textiles, something about the market prospects, and then I summarize. The presentation is partly based on the article with the same title published earlier this year in Forest Policy and Economics, and it's an open access article, so you can freely look at it. Thank you. Next. What are we talking about when we talk about wood-based textile fibers? These are man-made cellulosic fibers made out of wood. And these can be used like any other textile materials like cotton or polyester, etc. Currently, the main raw material for them is dissolving wood pulp, which is bleached chemical pulp with low hemicellulose content. That can be then further processed to viscose fibers like viscose, double, lyocell, and tensile. The next generation textile fibers are based on wood are on the way, and these would be even use less wood and chemicals than dissolving wood pulp. These are two names, but a few: JeanDenis and Spinova, for instance. Exciting thing for instance, in this Spinova method is that it allows direct spinning of textile fibers from the pulp grade suitable for that, without using any chemicals. Can I have the next please? But why are these fibers interesting in bioeconomy context then? It's the whole package, the environment and the economics. The environmental footprint is typically lower in these fibers than those of competing fibers like cotton and oil-based ones. And they are well suited for this kind of forest biorefinery production. So you can combine the production of many of those exciting products that were named in the previous presentation. So you could use specialty cellulose not only for textile fibers but also for other purposes. You could use the lignin for something else and then make something from the hemicellulose also, not only like liquid biofuels but also something more interesting, obviously. Next, please. You can do all the animations at once. Okay, thanks. This picture shows the market development of the consumption of some key textile materials from 1960s towards our days. In the last 20 years, these dissolving wood pulps, they have grown at the rate of 6.3% per year, which is a higher rate than the total market growth of these products, 4% per year. But the oil-based fibers, obviously, as you can see, they dominate the market. Can I see the next? Have the next, please. You can open the animations at the same time. Thanks. That's it. Yeah. What is alarming is this increasing consumption of textiles as such. That means increasing environmental problems. When we talk about oil-based fibers, we talk about microplastics coming to the environment, to the ecosystems. We talk about high greenhouse gas emissions. When we talk about cotton, we talk about a huge demand of land, pesticides, fertilizers, water, and also the production causes lots of greenhouse gas emissions. Even the modern technologies of dissolving textile materials based on dissolving wood pulp, they have less or none of these problems. It has been estimated that use of the textiles, the fashion industry, causes 10% of the global greenhouse gas emissions, which is more than the common emissions of aviation and maritime transport together. Can I have the next slide, please? But wood-based textile fibers, when they are based on sustainably sourced wood, they are more climate friendly than these main alternatives. The production of 1 ton of man-made cellulosic fibers made in this case, this study is considering Austrian production. You could replace 1 to 2 ton of CO2 when you replace cotton by this, or almost 2 to 4 ton of CO2 when replacing oil-based fiber. It's the polyester that has this coefficient 4, so it depends a little bit on the fiber there. Of course, it would be best to recycle the textile materials as much as possible, but in the end, if you incinerate these, then you also produce less greenhouse gas emission in this incineration stage when you incinerate man-made chemical fibers. Next one, please. Then another issue interesting to the climate change mitigation is that this textile pulp production is in synergy with the production of long-lived harvested wood product. These engineered construction materials that have also beneficial climate impacts compared to their alternative materials. The textile pulps are produced from a small-sized wood. Almost any wood species would do. And you can use sawmill chips and residues coming as a byproduct from sawn wood and plywood mills. So that gives synergy with the current technologies of producing long-lived construction materials. Of course, this fiber will compete over wood with paper, paperboard, and panel products. In the EU, these side residues are actually quite well already in use going to these products. So on the right side, you have a picture taken from the article I mentioned in the beginning. It shows you if we in the case where we have 4 million tons more of textile pulps produced, that would mean 2 million tons less paper pulps and 1 million ton of panel products. And you might have a small increase even in sawnwood and plywood production. But even if there would not be this increase, the sawnwood and plywood production would benefit from the increased competition and price for the residues. Next one, please. Then I have made some medium-term market projections for the wood-based textile pulps. This is up to 2030. It's based on the IMF GDP forecast from earlier this year, and it uses the same global forest sector model that I used in the article I mentioned earlier. You can find details from there. You see this projection estimates the production going somewhere in 14.5 million tons of wood-based textile pulps by 2030. But if you put this to the total market context in the next slide, please, you see that the market, if it would grow following the past demand growth pace, or actually a little bit lower than that, 3% per year in the next, up to the end of the decade. And if I would let the cotton to develop as projected by OECD FAO recently, and use the wood-based textile pulp projection from the previous slide, this is how it would look like. The oil-based fibers just continue growing. You can do a little bit more of the animation. This poses challenges for bioeconomy. How would we get this total 140 million, first of all, down? Because it's not sustainable development. Of course, there should be lots of recycling technologies going on for cotton and even this oil-based, although this doesn't take away this microplastic question if you recycle these oil-based materials. But how can we then also secure that we could even that amount of these wood-based fibers, or preferably maybe more to have favorable climate impacts? These are some of the challenges. Next one, please. Much of the capacity growth in the last decades have come from, in this dissolving pulp, have come from converting paper mills to dissolving pulp. But there has been some greenfield investment recently, for instance, in Laos and Brazil, and there are huge greenfield pulp mill investments going on in Brazil, for instance, by Brazil and Suzano. But lots of the mills recently have also been just like conversions from paper pulp to dissolving wood pulp. I have some examples here. Some of these mills actually are considering if they would go back to paper pulp or even possibly out of business. But it also shows the many materials you can use for making spruce, aspen, maple, birch, and of course the mainstream eucalyptus in Brazil, the wood species that are in use. And often these new mills, they can swing. They can choose between if they produce paper or textile pulp. So it's nice for the producer, because then you get less market risk because you can choose what is the best product for you. But for those who want to invest to the market and have some analysis of how this market would be like in the future, it just complicates the picture because you are not only competing with cotton and polyester, but also the paper pulp prices and demand will continuously affect your business. But it's likely that these conversions from paper pulp mills to textile pulp is likely to continue. Maybe in Europe it's the only avenue at the moment. But when consumption of printing and writing papers is still continuing to decline, that will liberate some pulp that could be converted to dissolving wood pulp of this next generation textile pulps, if not converted to produce unbleached kraft pulp for packaging applications instead. But these are alternatives for shutting down the mills to make something else with them. Can I have the next one, please? I think, yes, we are in summary. Yeah, textile market is growing in unsustainable manner. And it seems that the market share of wood-based fibers is and continues to be modest, at least in the short run. Still, wood-based textile fibers that are produced from sustainable sourced wood with best available or even better next generation technologies, they would remove or alleviate several of the environmental problems of cotton and oil-based materials. The production of man-made cellulosic fibers, it provides synergies with the production of long-lived harvested wood products, as the latter uses larger wood dimensions, the former uses pulpwood and residues. Of course, these engineered wood products could in the future also be done from smaller dimensional wood when the technology is up and coming, as was obvious from the previous presentation. Conversions from paper pulp are likely to continue, and they can satisfy some of the demand growth. But greenfield mills are needed to maintain and increase the market shares of wood-based textile fibers. But the question mark is if we get any of these greenfield mills to Europe. That remains to be seen. Thank you from my part.
Thank you very much for this very exciting presentation, Professor Caillou. I was impressed by your prognosis on the market share for wood-based fibers, which are very promising to me. We're slightly behind schedule, so we'll take one question before the coffee break, and I will ask a question both to Professor Rojas and to Professor Caillou. Let's start with Professor Rojas, but I will ask you the same question. There's a question that popped up in the Slido. The question is, good to add value to wood, but what about the costs? Also, logistics are vital regarding reuse and recycling. Now, Professor Rojas, what's your reply to this question? Professor Orlando, you're muted.
Yeah, I unmute. Okay, good. So a quick answer relates to the fact that in the future, as already is being implemented, we're going to see the integrated biorefineries. And in the integrated biorefineries, there is a main product like pulp, paper, and others, but then there are operations that are satellite and complement the main production units in such a way that residuals and side streams can be utilized in many of those advanced products that I indicated. That includes, of course, waste wood, but also lignin streams and others. So in that sense, the cost in integrated biorefineries where energy is rather cheap, I think is not an issue. When it comes to nanocellulose that was central in my discussion, I should say that around the world, there are many units popping up There are big investments by companies around the world, and that is a testament for the economic opportunity of producing nanocelluloses. If I give numbers, we have done some techno-economic analysis about the cost of nanocelluloses, and I can say that is rather competitive against fossil-based carbon counterparts. And I can cite the numbers, but the main issue is that per unit weight, the fact that we have a nanoscale material opens a lot of opportunities for the functionality. So it's rather competitive in that sense. But of course, there is still a need to increase competitive processes for leading from raw material to bioproducts, and especially to move from the lab to the commercial scale application. This is still something that we need to, a gap that needs to be filled. And of course, the market development for bioproducts. There is still a lot of work that remains to be done. And this, of course, will be impacted by policy programs, regulation and standards, and of course, working with science, technology, and knowledge. And I think altogether, I think the cost framework can be quite interesting and as a solution for future material needs.
Okay, thank you, Professor Rojas. I will ask the same question to Professor Caillou, to Maret, about the costs for wood-based textile fiber markets. What's your take on it? Maret, you're muted. Yeah.
Orlando certainly knows the cost structure of the technologies better, being in this engineering business. But considering textile, of course, the oil-based materials are the cheapest alternative still, and will be. So far, the environmental impacts are not factored into the prices. There is this problem. What I have seen of this new fiber, Spinnova, their own estimates of the cost, that would be a little bit more expensive than the current man-made cellulosic fiber, this stencil method, but there's not a big difference there in the costs of producing, for instance, one T-shirt of this material.
Good. Can you hear me? Yeah. Somebody.
Lost you again.
Thank you very much. We had some technical problems and we lost Hans Ingels. So on behalf of him, I would like to thank the previous speakers in the earlier session, Professor Orlando Rojas and Maret Caillou. And I would like to shortly introduce myself. And since I have the pleasure of doing it myself, I can just say I'm sitting in Brussels trying to coordinate the research and innovation activities of the whole forest-based value chain. So the earlier session, it came to remind me of when we did the whole work of having a forest-based sector vision 2040 and strategic research and innovation agenda, where we specified some challenges and targets when it comes to research innovation. So that is what we have to address and create more value and more sustainability. So the theme of this session now is the circular woody biomass-based value networks. And the idea is to highlight how mutual benefits can be created by pulling people together with innovation along and across the woody biomass value chains. So we will listen to some really interesting live examples from the forest-based sector's potential to contribute to the European Green Deal and also initiatives like the new European Bauhaus. So in this session, we have 4 speakers with very diverse background. And to you speakers, as you noticed, we have quite a short time allotted to each one of you. So I will time you, and after 10 minutes, I will let you know that 10 minutes have passed. And then I hope that you within a minute or so can round off your presentation. So hopefully we get the opportunity to have some questions. So much ado about nothing. Now it's time for me to introduce to you our first speaker, which is Professor Annette Hafner from Bochum University in Germany. Professor Hafner is an architect and a founder of the chair of resource efficient buildings at the Department of Civic and Environmental Engineering at the Ruhr University Bochum. She has conducted numerous research projects in the area of sustainable and resource efficient construction with her team. And she just won the German award for timber buildings together with the city of Munich for one of those projects. Annette Hafner is also a member of the Scientific Committee for Forest Policy, BMEL, and a member of various juries and expert committees. So, Professor Hafner, we are very happy to hear what you have to say. The floor is yours.
Thank you very much. So I'll welcome you, and it's a pleasure for me to show you my short presentation where I'll try to show you why building with wood is relevant on the climate discussion and what it means on a large scale case study from Munich. So next slide, please. Well, first about the context. Why are we talking about the construction sector? Well, as you can see here, the European construction sector accounts for a quite large number of energy consumption, of extracted materials, water and waste. And in the energy consumption, about 5 to 10% is located to the production of building materials. So this is quite a large number. Next slide, please. So I quickly talk about, we do have the Green Deal in European Union, and we do have, or I picked out 2 initiatives from the EU which could help to reduce the influence of building greenhouse gas emissions on a building scale. One is the renovation wave, where you could see on the left-hand side, I put some additional pictures for extension of buildings and closing building gaps, because I think especially the building sector on the building with wood could contribute to this sector, renovating buildings and additional creating more space. And the second initiative is the new European Bauhaus, which is a kind of holistic approach, which aims to at shaping more beautiful, sustainable, inclusive forms of living together. Here, the climate smart construction with wood could be a powerful tool to reduce the greenhouse gas emissions and in the same time generate eco-friendly living and also beautiful buildings. Next slide. So to show you us, I just picked some slides of recently built new buildings, office and residential buildings, and on the lower row, buildings which are renovated, closing gaps, or are extensions with wood. Not all of them are made with wooden material, but you can't quite often see it from the outside. So next slide. So how can bio-based building materials and building products be climate smart or positive in terms of greenhouse gas emissions reductions? Next slide. First of all, we'll talk about the substitution, which means that greenhouse gas emission can be reduced when a mineral building is replaced by a functional equivalent wooden building. From my research, we know on case studies that the reduction potential is between 10 to 40% per square meter of gross external area for a residential building, for example, which is quite a lot if you think about it. And the second part is the carbon storage in buildings. So buildings can act as large carbon storages, which we then in a second life or as in cascading use for other materials after they have served for the buildings. What we have to realize is that we have to design the buildings according to circular economy requirements so that we can reuse them afterwards. And for the purpose of the buildings itself, we have to assure building quality quite strictly and have to have an eye on durability and the quality of the buildings. Next slide. So having said that very theoretically, I want to explain it on a case study, which is the Prinz Eugen Park in Munich. Which the Prinz Eugen Park in Munich is the largest already built timber quarter in Germany up to date. And it was developed as research project from my chair and the city or the public city authorities of Munich together, and is realized by now. What is it containing? It's about 600 flats, around 65,000 square meter of gross external area. It's a quarter with about 8 architects with various different construction, which have all in common that they are all timber constructions. And the next slide, please. And you can see it on these pictures. These are buildings up to 7 storage, residential buildings mainly, timber constructions. Each architect used the timber in a different way, but all have in common that they had to build all their buildings in timber, which was kind of in advance as the city wanted them to build in wood. Next slide. What for me is important that beside of building in wood, we also have to think about resource efficiency, also by building with wood. And we, for that, need to aim creating much living space or space for whatever doing with the used material. So not always the mass timber would be the best solution. Sometimes various timber constructions could be the best. Next slide. And to show that on one exemplary building of that quarter, I'll show it on what you see the buildings right. It's a residential building, 3-story. It additionally has green roofs, gardening options, and includes community space. So all things we also want to create with a new European Bauhaus. And you could see on the left-hand side, for example, under A, they used floors in mass timber. Under B, the exterior walls are timber frame constructions, and insulation, for example, here is in cellulose. So different materials, woolly-based materials used for the same construction. All buildings had to be conform for building regulations in Germany, and although it in the beginning seemed to be a bit complicated, it was possible for all of them, and all the architects, 8 different architects, would right now do next buildings in timber construction. Next slide, please. So just to bring it on a more general level, the Prince Eugen Park project in Munich, from a climate perspective, was able to store, or is storing, 30,000 tons of carbon dioxide, and on the other hand, substitutes nearly 8,000 tons of carbon dioxide, which is quite a lot. On the other side, I put another quarter, which is from Hanover, a bit smaller, but also in mass timber construction. Here, the substitution potential was more than 2,000 tons, and the storage potential is 3,600 tons of CO2, which means, imagine you create new quarters and you tell the public communities they should build in timber construction, how much influence you could have on storing carbon and also reducing greenhouse gas emissions. So I do think it's quite an important issue to promote building with wood in an important way. Next slide. Coming to a conclusion, before building in wood or building the wood, we additionally also have to have the energy efficiency in mind. So all these buildings need to be, first of all, energy efficient and then built in wood. Then bio-based building materials can reduce the greenhouse gas emissions over the whole life cycle and additionally store carbon. For new buildings and also for renovation or extensions, this could be used, and that is a quite important issue which we should promote all over Europe. Third of all, various wood constructions are possible. There's not one solution which is the best. We always have to see the context, and all these construction have to be in line with the buildings regulations in the different countries. What additionally I think is very important if we build the wood right now is that all construction should apply to circular economy. And this means, for example, that we should not use harmful substances in this construction so that by the end of a building could reuse the building materials properly. Next slide. So in the end, what can I say? I do think that every carbon storage in building counts. Every reduction of greenhouse gas emission is important. And the need to combine these issues together with energy efficiency, with design and an additional social approach, as we have shown in this quarter in Munich. And then we come back right to the beginning, the new European Bauhaus. I think we do need this holistic perspective to really create the most impact from every side. Next slide. So that would it be from my side. If you're more interested in the quarter or the site development in Munich, there is a scientific paper which is named the Fandowi. You can read it, and all information how we realized that and what the public authorities had to do and how they promoted building the wood is included there. What I just want to finish off with, the public authorities in Munich are quite overwhelmed at the moment by the positive reply they get through that quarter, and they decided to go on with these discussions. And by now it's getting a kind of rule that half of the newly built social buildings have to be built in timber construction. I think this is a quite interesting perspective for proceeding building the wood. Thank you very much.
Thank you very much, Professor Hafner. Very good to have these examples. And I would also like to ask you a question. Now when you have pointed to some of the benefits of building with wood, and I'm sure you can add more benefits, like for instance the insulating properties of wood compared to concrete, what is the big bottlenecks to rolling out more building with wood in Europe, would you say?
Well, one of the bottlenecks probably is the building regulations, as they are different in every country, and in Germany in every state, which mainly serves to fire regulations. But I'm sure we'll find, or we'll have to find, solutions. We can show that there's quite a growing amount of buildings in wood. We just need to educate more architects and engineers to realize these buildings. But what we have to assure is that we need a quite rigid inspection of building quality. So we really have to get the buildings right. There's no possibility that building the wood is faulty.
Excellent. Okay, thank you very much. Thank you again, Professor Hafner. Now I would like to turn to Mr. Lars Fredlund. So Lars Fredlund is co-founder of Co-Builder, a company that is developing a platform for construction industry actors to enable operators in the woodworking industry to improve their competitiveness on the EU market. Lars is also a member of the Construction Products Europe task group Digitalization, BIM, and technical leader in 2 EU projects related to construction products regulation. Lars also advises governments and national and European associations on data aggregation exploitation, and works on the implementation of smart CE and data tables, and how it can enable Industry 4.0 and enable the European Green Deal and the circular economy. And then I will actually allow you to take the floor, Lars.
Thank you. So thank you, welcome. I will do a presentation on the work that we have been doing for the European Confederation of Woodworking Industries, CEWA. They have in March set up a work group that aimed to develop data templates for specific product types which is sold on the European market. It's actually 12 data templates. We spent approximately, I would guess, around 300-400 hours weekly meetings, and now we have finished this work. So next slide, please. So on a high level, I would say that what we have been looking at is the need of data in discussions between actors and also the complexity that we have on the European level, where we have climate change, increasing urbanization, and the need of becoming more digital. So next slide, please. So what we have tried to overcome is actually the gap we have in the industry, where we are looking at the raw materials, we are looking at the products that are sold on the market under different regulation. In this case, it is construction product regulation, where there is a need of actually CE marking, of course, the products, and the products are brought to market. So how can we close this gap between design, construction, operations, and recycling? So that's where we actually need to bridge the gap. So that is the aim of this project. Next, please. The complexity lies in, let's say, the EU legal framework and all the different initiatives. We know that there is a lot of different topics here, and it is important to understand that at this work we had to look at the real data on the product level. So there is two discussions there. One is the product, and actually the second also we could talk about species, like species of trees. And we are talking about both actually. But this complexity here, that is important because these products are manufactured under construction product regulation, where all the manufacturers has to distribute declaration of performances with essential characteristics of their products, which actually match the building regulations that Annette just mentioned. And this bridge between the manufactured product, actually the building regulation in each state, in each country and region in Europe is very important to understand. So the information that we looked at was environmental product declaration. So what is the environmental information, specifically embedded carbon in a product that is manufactured and sold to the market and then distributed to the market? We have discussed information on waste. What information on waste? We have discussed information on chemicals, is hazardous chemicals, circularity, and many other topics, which I think is important. That has been a part of this discussion, but one very important thing is that all this product has harmonized standards that already is there. This is a topic I would like to raise because we see that the CEN are developing standards in PDF format, so paper format. And what we truly need is a more digital format. So this bridge is what we are trying to let's say build to enable the manufacturers actually to be more digital, and the clients and the governments actually to be able to comply, check compliance and so on. Next slide, please. This brings in new behaviors. I mean, how can an architect look at the product and get all the needed characteristics or information that they need, depending on what they want to look at sustainability or technical requirements for products, and also that we have to, for sure, be able to measure what is the impact on a project as a company, because I think when we talk about EU Green Deal, each company has to measure footprints, and this is in reality what we're trying to address here. You have to measure, but then you cannot only look at environmental information, because you have to look at essential characteristics and as such on products, and of course the market is also looking at price and cost. Next, please. And here it comes, the work that has been done, where we have been working in CEN on BIM standardization. So we have developed standards on how to develop common agreed data templates, so that each actor, database, government, whoever, can have a standardized way of exchanging information between parties, or checking information that are sent between actors. And this standardization work is the framework of what we have done. Next one. So in this work, we have developed a data dictionary for wood, so that each property or characteristics of the product is described by the technical experts within Sebois. So it can be used and deployed to the 180,000 members to be used. And also, of course, external actors such as contractors or, I mean, as I mentioned, governments. And then we developed, from that dictionary, we developed templates which could support different use cases. And this is just a way of filtering information, so I can get the information if I'm a citizen, so I can get the information that I want, or if I'm an architect, I can get this information that I need or want. So the important part here is the link to the already existing EU legal framework, which is actually CEN and CENELEC standards, in some way also ISO standards specifically for EPD data. Next one. The aim here is then to drive the SMEs, because mostly these companies are SMEs, and to guide them on how they can send information as sawmills or actors to the market in a standardized way. So the templates is mainly guiding each actor, providing more like let's say the machine language on how this information is developed within your own organization, and then also to facilitate work on circular economy. So what information and what processes do we need to have in place so that we can actually get this data also machine readable, which is a very important thing. Next slide. So this slide is a slide that comes from Construction Product Europe, and we put the data templates in between construction product regulation, environmental product declarations, and all the different initiatives in Europe, because we need product data. We cannot build buildings without information from the manufacturing companies. It would be difficult. And this is merely just a framework for that. Next one. This slide is just like an example. There is a generic template which could be used by anyone, but as soon as you put some values into it, it becomes a real-life product sold on the European market. This would enable the companies to send declaration of performance. Smart CE marking is an option here, where you can send this declaration of performance electronically, and you can add data on carbon footprint and as such. Next one, please. So the project that we have been looking at, yes, 1 minute. The project that we've been looking at is looking at the whole life cycle. So from the tree cut down, where we want to identify, like we do where I come from in Norway, we identify a cod where it is caught, who is the fisher, and so on. So we need to actually track that, and that is where we work with an organization called GS1. To actually implement standards for identifiers that you can use in the different stages of a life cycle of a product. The data template is merely to feed the information on the product level. Next slide, please. And this could apply for, of course, any type of product. What is important to say is that what we are now looking at, the next stage now, is to develop data template for species, meaning different types of wood, so that there is a common definition on the species and all the characteristics of the species. That is the next. And then I think we should sum up with the next 2 slides forward, Johan. One more. So this is the work that we have been doing, and this is ongoing now. So now we are working with several from a European level down to a national level, where there is amendments in standards and need of additional information around the different product types. And this is now the next step for the next 6 months. So I think that's it on the work for Sebois on developing data templates. Thank you.
Thank you. Thank you very much, Lars. That was a very good presentation, and I remind the audience that you can actually ask questions via the Slido. If you don't do that, I will take the prerogative to ask one short question. As I understand it, this tool now is supposed to help the Sebois members to fulfill the many regulations and standards, etc. But do you think it will require a lot of training if you roll this out?
It's more like, I would say, it's more like you have to go on LinkedIn and you have to register. You have to, maybe if you want to be an advanced user, you have to have a training session. But it's the whole idea is actually to make it available for the members. Because the association actually is guiding the members, because they need some sort of a trust, and we need to have a trust in the data also, not only on the platform, but actually on the data, which is actually going to be used outside of this platform. But the data templates is kind of the aim for this first step.
All right. Thank you. Thank you again, Lars, for that very good presentation, and good luck now with the rollout of this.
Thank you.
So now we will turn to Ms. Veronica Shea from Step Change. She's the CEO of Step Change Consulting and an industrial focused and independent, which is an industry focused and independent management consultancy specialized on wood, pulp, paper, packaging, and tissue, with a proven track record in supplying clients to achieve sustainable value. Veronica concentrates on strategic industry topics, sourcing of strategic raw materials, and managing performance change. She has experience from living and working in many countries across different continents. And prior to joining Step Change, she has been responsible for various strategic and operational projects for both Fortune 500 companies as well as other companies. So we are very pleased to hear your presentation, Veronica. Please, the floor is yours.
Thank you, Johan. Good afternoon, ladies and gentlemen. It's a pleasure being here today. I will be talking about opportunities and challenges for the pulp, paper, and packaging industries. These are the industries we focus on. We move to the next slide a bit, please. So what we see is that the world is changing. So if we look at the world today, it's much more different than the world that it used to be a few years ago. So we have now a full new generation of digital natives. And today we're all used to have the world on demand and on a click. So everything is very close to you. We are all connected somehow. And yet also a lot of going into also individually from remote. We are leveraging the new technologies more than ever, and we are always on the move. Tracking and being tracked in real time, it's a reality today, so it's nothing science fiction for the future. And the question is how this can be leveraged for the industry as a whole. If we go to the next slide, what we also can see is that there's significant value which is being invested in technical startups today by venture capitalists. So there are now more decacorns. So for those of you that are not familiar with the term, a decacorn is a company which is valuated at more than $10 billion US. So we used to talk about unicorns. So unicorns are the companies that are valuated at more than $1 billion, and decacorns are 10 times that. And today, or this year, we have more decacorns than there were unicorns 5-6 years ago. And there are more which are expected to come or to become valued so high. If you go to the next slide, as I mentioned, there are a lot of resources that are going into those high-tech solutions. And these new solutions are somehow revolutionizing traditional businesses. Now we are talking about transparency and real-time value chain visibility in a way that was not possible before. So the industry was talking about such solutions already for a long time. Nowadays, they're reality. So it's possible now to connect different players to create value and increase efficiency along the value chain. There are solutions like Gorillas, Sender, among others. They're just on the way of becoming really important. So if you go to the next slide, if we focus now on pulp, paper, and packaging, what we can see is that they are lagging behind the S&P 500. We can also see that there was a major drop in market valuation related to Corona. And what we can also see is that this major drop of 23% was overcome within a few months. So in November last year, the industry or the market capitalization of the industry had fully recovered and now had already reached new levels of market capitalization, new peaks actually in 2021. So there is a big boom market. If we go to the next slide, we look into more details into the different segments of the pulp and paper industry. We can see that all the segments have increased their profitability. Tissue is a bit of an exception 2021, but it had a major record year in terms of profitability in 2020. So it's a bit lower this year on the half of the year. All the others are really extraordinarily profitable, especially if we talk about pulp and wood products. Of course, we were talking about wood buildings, construction, so there was a big capacity increase, but also a huge demand increase, which resulted also in higher prices. We go to the next slide. We conducted an industry survey in cooperation with CEPI, this is the Association of Pulp and Paper Producers in Europe, to assess the digitalization level of the industry, and around 300 participants participated in the study. And if you go to the next slide, one of the key major results, what became very clear is now that digitalization is finally on the roadmap of the industry. By now, close to 1/3, so 32% of the players, of the producers, are already implementing some digitalization projects. And this was quite different 5 years ago. So 5 years ago, it was 29% hadn't started yet, and only 6% were in this stage of implementation. We go to the next slide. It also explains why we're talking about digitalization, because there are really very clear short-term and long-term benefits. And here we are talking about cost reduction, increases of efficiency, higher flexibility, but also, and very important also, increased safety and improved sustainability, which has become a more important topic in the last days and months. On the challenges part, the key challenge has been already discussed today. So attracting and retaining talents, it's very crucial. Okay. If you go to the next slide. And this is a result of the study as well. Here we can see, based on the survey and as well based on our experience working with the clients on the different sites and the different mills across Europe, but also across the world, that the main benefits, they lie on the operational areas. So it's really increasing productivity, improving quality, enabling faster and most efficient supply chains, and also very important, and especially when the energy prices are so high, increasing energy efficiency. You go to the next one. And this is also very important. Additionally, digitalization will be a catalyst to boost this decarbonization and so help the industry achieve their carbon neutrality targets. So the target is to reduce emissions by around 80%, and 50% of this is expected to come from digital initiatives. So digital solutions will help the industry reduce around 24 million tons of carbon emissions. We go to the next slide. Here is a bit of the good news, because these are the challenges that have been perceived by the managers. And we can see that the main challenges, they are all somehow under the control of management. And managing change is perceived to be key. So here, important question, important answer actually, or topics to work on is working on managing change will become more and more relevant. If If you go to the next slide, you're already there. So here it's also the different areas where management can focus on. And here we say there are 7 key areas that management should focus, and all of them can profit significantly from digitalization. So we're going from production to the administrative areas, considering the whole value chain, including your clients, but of course also including all administrative and productive resources, so your employees. And finally, to put everything on a summary. So here, as mentioned, the world is changing, the pace is increasing, so change is coming faster than ever, and industry is, although it's a slow mover, is catching up with the rest of the world. The overall market trends continue to be intact, so there was a full recovery and it has reached new record levels. The prices are high for all commodities, but all type of paper and packaging segments, from pulp to packaging, and the demand continues to be strong. Digitalization has finally become very important topic, and it's already on the top management agenda of most companies in the industry. Adopting those new technologies will deliver value and support decarbonization, and change management and skills are the biggest challenges. So all in all, the outlook remains positive. And thank you very much. Here you have my contact details.
Thank you very much, Veronica, for this excellent presentation. And very, very briefly, very shortly, what would you say now, with all the digitalization that has happened during COVID, which is the biggest challenge or opportunity for the pulp and paper industries? Is it the digitalization to adapt the products to this new market, or is it the digitalization in the process, so to improve the production process and the value chain management?
Definitely on the process side. So there, of course, there are some improvements can be done on the products themselves, from pulp to paper, some qualitative characteristics. But if you look on the process and the production and operations, that's definitely the biggest lever.
Thank you. Thank you again, Veronica, for that very good presentation. And now we will turn to Mr. Eddie Snaidero. Mr. Eddie Snaidero, he is the president of the European Furniture Industries Confederation, EFIC, since March 2021, so March this year. And Mr. Snaidero is also chairman of the board of directors of the Snaidero Rino SPA and representative of the kitchen sector within the Italian Federation of the Woodworking and Furniture Industries, Federlegno Arendo. So during his 30-year experience in building this pan-European group, he acted as CEO or chairman of several companies in different European countries. So we will greatly enjoy your presentation, Mrs. Snaidero. You're mute.
There. Okay. Good afternoon, everybody. Thanks for inviting me to this very interesting event. Of course, I have brought with me a small presentation which will help in my intervention. I'm president of EFIC. EFIC is the European Federation of the furniture industry. We represent almost 70% of the furniture industry in Europe. Next slide, please. So as you can see, most of the most important countries in Europe are represented by EFIC. And more than that, in the next slide, if we can go to the next slide, you can see the figures. We represent basically 1 million employees, which is a very large number of employees, direct employees in the furniture industry, and 120,000 enterprises, mainly, I would say 90% very small companies made by a few number of people, but altogether they make a very big number. And in total, we represent 40% of the total world trade of furniture. Getting to the next slide, EFIC main policy of interest. So of course we do advocacy in Brussels. We follow single market activities, environmental and circular economy, which is today the main focus of our federation. International trade, social dialogue. We members of the social dialogue, and also other transversal topics like standardization and, of course, intellectual property and so on. So very briefly, what EFIC is and who we are representing. If we can go to the next slide, okay. Thanks. Of course, the European furniture industry, the European Green Deal sets ambitious commitments to tackle climate and environmental related challenges and to achieve a climate neutral economy by 2050. A more circular economy is a key enabler of these goals. The European furniture industry welcomes these objectives of mainstreaming a circular economy and is ready to be involved in making it a reality, of course, with a reasonable transition period. From a circularity point of view, furniture is a complex product, and the same applies to the furniture value chain. The product range is very varied, so it goes from chairs to kitchens to bedroom foam. And on the other side, also the materials used are, of course, wood is the #1 material, but we are using almost all materials: wood, plastic, textiles, steel, glass, composites, foam. And many suppliers are involved. And finally, also, the distribution is quite complex because we go to, if we speak about B2C, through dealers to the final customer. So it's the complexity of this value chain has also been palpable during the coronavirus pandemic, which brought uncertainty to the industry, is bringing today uncertainty, as it experienced shortage and increased price of key raw materials, including wood-based products such as panels. This in turn translated into delays in deliveries to the final customer, of course, problems to the companies, costs, and of course, finally, the price will increase. This issue has been raised with the European Commission and not only by the furniture industry, of course. So if we can go to the next slide. What is the role of wood in climate neutrality and circular economy? Although a variety of materials are used in the manufacture of furniture, the most important raw material in terms of volume is wood in the European furniture industry. It is an excellent material choice when it comes to promoting circular economy, and in particular for limiting emission of greenhouse gases. Wood is renewable. Wood binds carbon dioxide and thus acts as a sink. 1 ton of wood binds 2 tons of carbon dioxide. The use of wood is in the furniture industry is resource efficient, as you can use solid wood and get very long-lasting products. But of course, also wood waste, sawdust and recycled material to make, for example, particle boards, which makes it possible to upcycle waste into valuable products rather than using it for incineration. Provided that wood is sourced from well-managed forests, it is truly a raw material that can and should be used. The EU was out early with strict forest management legislation, namely UTR, which is now being further developed. In addition, the industry works extensively with various certification systems, such as FSC and PFC. If we see what the results of the extension of forest area in Europe in the last decades, we see that from 1990, we went from 185 million hectares to 202 million hectares in 2020, which means that we are using wood, but we are also using it properly, and the growth of forest is important. Another example, in Sweden, for example, the growth is, for the same period, is 120 million cubic meters, with the extraction of 80 million cubic meters, which means that they have a net growth of 40 million cubic meters. So can we go to the next slide? So sustainable product initiative. One of the key initiatives for furniture sector at European level is the upcoming sustainable product initiative, which aims to make sustainable products the norm in Europe. The initiative will have a large impact on our industry. It is important because it will address product groups identified as a priority in the Circular Economy Action Plan, such as furniture. The future proposal for a directive will aim at widening the scope of the current Eco-Design Directive to cover non-energy related products. It will address design for sustainability, but also the responsibility for information along the supply chain via electronic product passport, implementing circular business models, among others. EFIC has been heavily involved in the consultation process, providing recommendations from the industry perspective on this important future piece of legislation. Some of the key recommendations are to take an holistic approach to establish harmonized legislation at EU level, including definitions, to involve industry and standardization bodies who are working on standards concerning circular economy in the future in the furniture sector, to consider a value chain and ecosystem approach, consider the complexity of the furniture value chain and of the product itself, but also the distribution system as explained above. To grant flexibility to the transition to incentivize demand for circular products, to make sure that circular economy is sufficiently addressed in research, to apply the same rules to important products, and to strengthen market surveillance. And to consider finally the global aspect of the industry, which is highly oriented towards international trade. So many recommendations. It's a key point for our industry, but it's important to tackle that in the proper way. So coming to the product passport, to the next, please. The introduction of product passport can indeed promote the transition to a more circular economy if they are designed in a proper way and are designed to facilitate a more circular economy. Choices of furniture consumers are driven by different factors. Therefore, the EU-level information scheme on the main characteristics of furniture products should allow consumers to compare different products on the market, make environment-oriented decisions by choosing the most durable and resource-efficient ones, and reward manufacturers who invest in the quality and sustainability of their products. But it has to be considered. As of today, there are very few compulsory information systems for furniture products. One, for example, is the Italian compulsory product sheet. Another one in France with a general information scheme for new furniture and furnishing, a label and identification card. And Ireland with a specific information scheme on upholstered furniture. The rest are voluntary schemes. We have to consider the amount of energy and associated carbon footprint needed to operate large databases linked to the product passport. It is important to ensure that the actual development of the product passport does not in itself entail an environmental impact. We have to consider the complexity of product and value chain, as well as the quantity of data required via the passport to avoid duplication of reporting. Also consider the difficulty with access and reliability of data for products with extended supply chain. We have to consider the interoperability of the tool within the supply chain. For example, the availability of information on certain chemicals or materials depends on our suppliers. So we cannot have everything clear. It must also be possible to control and verify the information to be included, and supervision must be exercised and given the necessary resources provided to maintain a level playing field in the market. Data that is not possible to verify has no value and should not be included, as it risks becoming misleading and can result in an uneven playing field between products. It is important that market surveillance of product passport is coordinated and conducted in a systematic and equivalent manner throughout the Union.
Can I ask you to round off?
Sorry?
Can I just ask you to round off the presentation, please?
Yeah. Can we go next? I don't. Okay. Sorry. So we can go to the. Yeah. Okay. Perfect. The tool. It should be based on existing legislation and standards. Several different standards and systems for data sharing is in value chain already exist on national and European level. It is important to use information held in these existing systems in the development of product passport, and if necessary, supplement these systems and enable readability between systems. The tool should be based on common definitions and measurements, binding on standardized data set, which will increase accountability and reliability of information. The tool must not become an administrative burden to companies. It's too, you are too far ahead. Can you come back with the slides? We're still on the passport, thanks. The tool must not become an administrative burden to companies. To avoid excessive administrative burden for companies, especially for small and medium-sized enterprise, information included in product passport, it should be taking consideration that more than 100,000 companies are very small enterprises. The information to be provided via the tool, certain information cannot be disclosed under any circumstances because it is a trade secret and linked to intellectual property rights. Chemical content, for example, we have to minimize the administrative burden and weigh the cost against the benefits of chemical content reporting. Only chemical substances that may impede circular economy in terms of recycling, remanufacturing, or reuse shall be subject to reporting. Legislation such as REACH must be fully harmonized with the product passport. Materials. Manufacturers may have difficulties in providing a detailed list of materials when they manufacture customized, custom-made products. Recycled content. Information on recycled content should be provided on a voluntary basis. Information on the origin of product could help in fight against counterfeited products from third countries and could bring benefits on circularity in the sense of that sustainable practices of EU companies should be promoted to customers who associate certain countries with very high environmental standards. However, if such information is to be provided, it should be on the final product and not on components or material source.
Mr. Snaidero, I'm afraid we're running out of time. Could I ask you to come to your conclusions, please?
Of course, of course.
Thank you.
Of course. So, although welcome must have a practical, we must have a practical approach. The information in the product passport should be based on need to have basis and limited to the necessary information for target audience or target operation, end user, customer, waste operators, and recyclers, or for the purposes of repair, exchangeability, upgradability, and separability. A small middle enterprise may require extra guidance and support. It is vital that the requirements for product passport reporting are established at a reasonable and manageable level. So I have a lot of other points to discuss, but of course the time is limited, so I will stop here.
Thank you. Thank you very much, Mrs. Snaidero. We're all prisoners under the clock, I'm afraid. I'm afraid that we have to round off this session now as the time is out. So I would like to join you all with a warm virtual applause for our 4 speakers. And before thanking for myself also for sharing this session, I would like to present the chair of the next session, which is Mr. Peter Verheim. So Peter, he's the head of unit for the Bioeconomy and Food Systems unit within Director General for Research Innovation in the European Commission here in Brussels. Prior for this, he also worked with Phil Hogan, the former Commissioner for Agriculture and Rural Development. And from 2010 to 2018, he was also working as head of unit in DG Klima. So we have that experience in his backpack as well. He has a doctoral degree in agriculture economics from the University of Gießen, Germany, and apparently also he comes from a winery in southern Germany. So thank you for myself, thank you to all the speakers, and Peter, the floor is yours.
Johan, thank you very much for that kind introduction. Good afternoon, dear participants, and very warm welcome specifically also to our 4 panelists for this last session in this afternoon's seminar and in this panel discussion on disruptive solutions from circular woody biomass. Very pleased to be chairing this panel discussion on disruptive solutions from circular woody biomass. To me, it seems like a meeting of the friends of the circular and sustainable bioeconomy. I think we all share the views that the forest-based industries have great potential. Following the 2 previous sessions, this panel will look indeed into the important advances in the forest-based industries, which are vital part to progress with the bioeconomy by making contributions to the green and digital transitions as outlined in the industrial strategy. Let me welcome our 4 panelists. We have excellent experts and representatives from 4 European organizations. Namely, let me firstly welcome Silvia Melegari from the European Confederation of Woodworking Industries. Welcome, Silvia. Silvia has been appointed Joint Secretary of the European Confederation of the Woodworking Industries and of the European Organization of the Sawmill Industry in September 2020. Since 2015, you have worked for the European sawmill industry and have been advocating for the interests of the European mechanical wood industries. And prior to that, you have worked for the European Panel Federation, hence a broad, relevant experience. Secondly, let me welcome Clive Pennington, CEO of the European Panel Federation, and welcome to you as well, Clive. You are a business leader with 25 years of experience in business-to-business management of industrial products, and your most recent award-winning assignment refers to advising on market growth and product expansion into wood-based panels, culminating in a key 12-month supply agreement with an industry leader. Again, great expertise you are bringing with you for this panel. Thirdly, let me welcome Director Anna Papagrigoraki from the Confederation of European Paper Industry. Welcome, Anna, to you as well. You are the Sustainability Director at CEPI since 2019. Prior to CEPI, you have hold positions in Plastics Europe, where you were also part of the advocacy team and the EU Sugar Manufacturers Association as an environment and agricultural advisor. Fourthly, let me very warmly welcome Mrs. Ylva Alvarsdottir, Director of the European Chemical Industry Council. Welcome to you as well. You are a member of several groups in the field of bioeconomy, sustainability, trade, and industrial policy. You have also been the head of the Swedish delegation within standardization of bio-based products. And I think we have great experts here. And the topic we would like to discuss with you aims to identify big tickets which have the potential to speed up the green, digital, and more resilient transition with the help of solutions from forest-based industries. I think, as we have heard earlier in the other sessions, disruptive solutions from circular woody biomass solutions are not only strengthening and diversifying traditional uses of woody biomass, but also drastically expanding cutting-edge use of woody biomass residues for completely new, functionally better and more environmentally friendly applications. Hence, they should be and could be win-win solutions. This means better packaging, construction products, food, chemical, medical, battery, electronics, sensor applications, intelligent and other textiles, contributions to e-mobility, car and aerospace industries. Hence, we have a broad range of examples to look in. On the choreography of this session, let me just say that I will ask the four panelists to present in a relatively short and snappy way, 3 to 4 minutes each. First of all, the leverage of their examples of their solutions, the leverage now by 2030 and by 2015, giving concrete examples and actionable and scalable solutions. After that, I will ask a couple of specific questions that will help us in the end to identify these big jump tickets, especially in view of the pathways needed for the ecosystems of energy-intensive industries, construction, textiles, and mobility. Now, on the leverage points for now, 2030 and 2050, I would first like to ask Sylvia to kickstart with a brief presentation on the leverage of disruptive solutions on circular woody biomass in your sector. Sylvia, please, the floor is yours.
Thank you very much. So you have mentioned a lot of product in your starting speech. So that's make me almost concluding that there is no doubt that the forest-based industry can really play an important role to transform several strategic sectors, like, for example, the construction, the textile, but also the plastic. And why this? Because wood is a biodegradable material that can be used for creating reusable, recycled material, but also material that are less energy or carbon intensive compared than others. So we have seen during the entire seminar today that there are plenty of wood application that can allow a green and sustainable growth in Europe. Wood can be used in construction material for furniture, flooring, window, or other musical instrument. But as well, it can be used for civil engineer products. We have seen now the development of a CLT that allowed the building a skyscraper in wood. But also, as Clive will present, we can create important insulation material for our home. But this is not all. When we look at the wood product, we are also a very resource efficient sector. And why this? Because wood from mechanical waste and byproduct can also be used in other production for producing sustainable alternatives of a high value application such as plastic, you have glass. You have seen it early this afternoon that there are also wood transparent products that are made out with lignin, but also additive for animal feeds or cosmetic. Now, if you go to the next slide very briefly. So how can we predict the future in 20 or 30 years? But probably this is impossible. We have seen what COVID has brought in our society. It was a big change that nobody was able to predict. But I can mention a few of the disruptive technologies that will certainly bring a change in our sector and that are very important. In this, we have the application of digitalization and genomics. Why this is important? Because when applied to forest management, it can lower the cost and improve silviculture investment. Then we also have another important factor, that is automation and advanced manufacturing. This, it can help the wood industry to replace the labor force that we are not able to attract, but also to speed up production. And this, again, it's very is essential, particularly when you compete in a world market. And then last but not least, we have the application of 3D printing. While the 3D printing can be used for creating models, it can also be an advantage for the wood industry when you use the residues of wood chips. Now here in the picture you have a little megaphone that has been produced with a 3D printer, and this is just an example, but using this granular powder made from wood chips, you can also produce, thanks to the 3D printer, other products that otherwise you would be able to realize using a traditional woodworking method. So it really gives a new way of design. So how do I see the future? The future, I think, is more digitalized, more innovative solution. And I think the wood industry, when it comes to new product, we should look more at this partnership with the R&D sector. Thank you.
Excellent, wonderful, Sylvia. And also thank you for keeping the time. I think you already presented some inspirational ideas and outlooks. Let me directly ask Clive Pennington to come in, the CEO of the European Federation, to start with your opening remarks, please.
Thank you very much, Peter. I think my slides will be shared. Yes, just if you go on to the next slide, please, that would be great. So it's rather hard going at the end of the day because a lot has already been discussed. So I'm going to skip the first bullet point and the last bullet point. You've already had a lot about wood in construction, wood in furniture, wood in packaging. These are all areas where we can add value without question. Likewise, the solutions, we'll talk about them next. But I do want to talk about the two middle bullet points. First one, wood-based panels, role models. On climate, we've talked a lot about it, but no one has mentioned the figure that I like most. The forest-based industries make a 20% positive climate contribution compared to all EU fossil emissions. So that comes from sequestration in the forest, comes from storage in products, and it comes from substitution for high fossil intensive products. But for me, that is a fabulous figure and needs to be spoken as often as possible, hence why I'm doing it now. A second figure I think is arresting, and this is probably the one I'm most proud of. We represent particle board. Only 25% of a European particle board, on average, comes from roundwood. The rest is coming from either recovered wood, recycled wood, about 44% on average, or industrial byproducts from the sawmill, 33%. So only 25% is from roundwood. And in some countries, that's almost nothing. In some countries, it can come almost entirely from byproducts or recovered wood. I think that's fantastic. If we want to look at disruptive solutions or better ways to build, let us start there. Sylvia referred to it earlier, the next point, innovation, wood fiber insulation. We do need to insulate better. We need to reduce our energy consumption. We need to do that with insulation materials. They are not only fossil-based, there are also wood-based ones. So why aren't we logical? Why aren't we seeing more of these used? They represent 1% of the market in Europe. It's by far not enough, and I would very much expect it to grow, and we will certainly do all we can to promote that. For all this to happen, we've got three challenges, in my view: status quo, harmonization, and the elephant in the room, wood availability. status quo, change. Who likes change? I do, but a lot of people don't. And certainly when it comes to building houses, building offices, refitting, the tradesmen like to stick with what they know. We need to change that. We need to change that mindset. We need to encourage society to use nature-based materials as climate-friendly alternatives to existing ones. Harmonization, I think it was referred to by Mrs. Hafner earlier. We absolutely face this. If we can harmonize building and building regs around Europe, it would help tremendously. And then wood availability. Our forests are very precious. They act as a carbon sink. We need to make sure that the wood that is consumed from them is used in the best possible way. And we don't want any market distortions from subsidies. We hope for a level playing field, but we need to be very careful that we guard enough wood for climate positive industries such as our own. Solutions will come to next. So that's all I'd like to say at the start. Thank you.
Excellent. Thank you so much, Clive. This was another set of very important points you made for the introduction. Let me directly hand over to Anna Papakrigoraki and ask her to come in and with her opening statement. Anna, please.
Yes, thank you, Peter. So I think what we should start off with is by saying that as CEPI, we share the vision of the EU Green Deal for an ambitious circular, low carbon and competitive industrial transformation, while also keeping production in Europe. So for that reason, our industry aspires to be the European hub for the bio-based economy, but that cannot be done without collaboration in the value chain. And in order to be the hub, we have a series of disruptive solutions for 2030 and also for 2050, as far as we can look at in the crystal ball. So without further ado, maybe we can pull up my slide and I can take you through it and try to be on time as well, because I know time is of the essence. So I think when we look at disruptive solutions for 2030, and I'm waiting for the slide to come up, I would say that we have to look at it from different angles. And normally, what we would be able to see on the screen, no, that's not the right slide. I'm sorry, I sent another one. Okay, how do we do this? Do I keep talking without my slide? What do you prefer, Peter?
I think that would be the best way forward to save time. The colleagues, the technical colleagues will try to find the right slide, but please continue.
Okay, let me wing it, like people say. And then we see how far we go, okay? So one of the first angle is increasing resource efficiency in processing and also recycling rates. And normally what you would notice is that the recycling rate for overall paper and board in 2020 increased to 74%. But of course we can further improve it by increasing the amount of recycled fibers and residues that we use from other sectors. That's why it's key to have collaboration with the value chain, especially when it comes to products that are hard to recycle, such as on-the-go food packaging. Then we need to talk about material substitution. So anything you can do from fossil, you can also do from wood. And I'd like to give you the example of packaging, and especially packaging, fiber-based packaging that still has plastic-based barriers. And that is, let's just say, a backlash of the SUPD directive. Now the question is, can we do it all from wood polymers? Now I would like to give you the example of MedGen from Finland that was awarded the overall 2021 Innovation Radar Prize for the game-changing bio-based solution to replace petrochemical wax-based solutions currently used in cardboard packaging boxes. So now, if you replace these petrochemical wax-based solutions in cardboard packaging boxes, you can ensure that cardboard packaging is easier to recycle and less of it ends in landfill. So that's one example. but also using lightweight foam material made from cellulose, which is an alternative to expanded polystyrene polyethylene for packaging. And that was cellulose foam by Stora Enso. Then we have to think about energy efficiency of the production processes, decarbonization and using electrification. So of course we have to increase the energy efficient production, minimize air emissions and reduce CO2 emissions. And for that we also need CO2 capturing technologies, which will contribute to the decarbonization of the industry. Then, and this is something the colleagues touched upon, expanding the product range to bio-based products. And when I think about that, I think about things like textiles. So Metsä Group developed a new energy efficient process to produce high quality cellulose fibers for the textile sector based on a new solvent family. And these cellulose fibers can be produced from paper grade pulp, avoiding the use of energy intensive dissolving pulp, which is promising in terms of ecological and economic advantages. So we can tap into further markets for sustainable textiles. Also, funnily enough, did you know that we can produce batteries and battery cathodes from lignin to replace graphite? That is also something done by a company, Stora Enso in particular. And then we have wound dressing from UPM Biomedicals, which is made from nanofibrillated cellulose. And by 2030, it should be a norm in the market, so hospitals can have access to it all around Europe. Then we look at digitalization, and we see that also when it comes to sourcing and sustainable forest management and processing. So companies can use a mapping method to track the health and state of the forest, check the sourcing of the fibers according to certification schemes such as BEFC and FSC. And finally, minimization of emissions and effluents in improving the environmental performance of products. So one thing is investment in clean technologies. The other thing is also industrial symbiosis. It will be the key to have new solutions to reduce air and water emissions, but also waste. So actually, if you think about the Industrial Emissions Directive, it's also about implementing solutions to reduce overall water consumption, close water cycles, mitigate pollutants such as microplastics. So that's 2030. 2050 now. Well, lovely, perfect timing. Check the graph with the little bubbles and see that you have an evolution of the products, okay, from now to 2030 to 2050. Look at the little circles. And what you have to know here is this is cumulative. So it means that it doesn't mean that we will stop producing paper. It doesn't mean we will stop producing our traditional product range. It means that we will expand it to further product categories. And it will end with the ones that are medical applications. And I think in order to do that, we need the available technology. So the product range will be expanded according to the evolution of the technologies and also the technologies that reduce emissions and achieve full carbon neutrality. And we will also be looking at fully autonomous mills, bit of a plug and play kind of system, if I'm allowed to say that. So what do we see in the 2050 crystal ball? Fit for purpose and lean design, maybe interactive packaging, that would be nice. Maybe using product passports for digital technology applications. Completely fossil-free and climate-neutral, non-toxic industry. And then further expansion of the product range. And for that, I'm thinking nanocellulose and 6G, which is an example we have from the University of Oulu. So maybe a glass ball composite lens made of nanocellulose for 6G frequency. That would be crazy. Imagine if that enters the market and it's used and it's taken off the shelves. I'd be pretty impressed. But something that I really think is special and it's close to my heart is what is close to the health sector. So using polymers such as nanocellulose for bone tissue replacement, because nanocellulose is a natural polymer. And I think it would be interesting if you could see it in order to regenerate bone tissue, but also serving as a drug carrier for treating diseases like osteosarcomas. I think that would be something that would be wonderful. It's something that is very much needed. It's a bit crazy to imagine it right now, but I just would love to see the application of the wood-based sector, forest-based sector into the medical field, and hopefully we will be able to touch upon it later. And of course, we will have flexible production, changing what we produce, textiles, pulp, and so on. Easier said than done, but we have to think 2050. And new processes to make them more efficient, such as new pulping processes. This is what I have to say for now, Peter, and I look forward to the rest of the discussion.
Anna, thank you very much, and sorry for the technical difficulties in the beginning, but you have done an excellent job in presenting, yes, the leverage of your solutions, also in the long term. We'll come back to some of these very quickly, but now let me also, last but not least, ask Ylva Alvarsdottir from the European Chemical Industry Council to come in, and yes, curious to hear also from you what role for the chemical industry you see in all of this. Ylva, over to you.
Thank you very much, Peter. So I'm representing the Biochem Europe. So that is a sector group of CEPIC, and we work with biomass-derived chemicals, and that is regardless if it's lignocellulosic or if it's other kind of biomass or what we call the first generation. And I would like to relate to Professor Roja's inspiring presentation before. If you could project my picture, please. So what is actually going to be commercialized now? What is commercialized already? Can we see my picture? And I wanted to use the Borregaard plant in Norway, where they have been able to develop more and more niche products, because there is a market for niche products, and with all the specialities, they can actually get the payment needed. Since in most of the cases it's more expensive, thank you very much, to actually produce these. So this is really, you see the gray stem wood, and where traditionally you have produced the pulp and then you burn the lignin. And in this factory, they're actually producing different kinds of fibers, not for pulp anymore, but specialities going into almost all kind of products. But you're also using the small residues, what we call fibrils. They are using the lignin and developed that into polymers. And they have been many years actually been producing vanillin, 10% of the world market. That's really, really impressive. So this is a work been ongoing, and they are, well, as number one, I would say, in the pulp mills. Another example I wanted to show is the UPM, which are building a new plant in Germany based on beech. So it's sawdust from beech or wood chips from beech, because there is availability, and beech is not so easy to work with. But they have developed a technology to fractionate then the forest residues into both the sugars coming into the could have gone to ethanol, but then also the lignin part. And they will make both the drop-in products like monoethylene glycol into plastics to PET, or polyethylene glycols, for example, de-icing. But these products really can be used for more or less everything. And we see niches where it's a huge demand. They've also developed a completely new filler or replacement for carbon black. And this we will see, I think, until 2030, more and more of the forest industries coming into, well, the chemical production. So it's going, I mean, widen their production as such. But the big challenge is also the traditional chemical industry, where we have to include biomass in the production. Is important both for the forest base, because they need also the help. They need the additives and other part for, I mean, the barriers for their production, but also that we becoming climate neutral. And that's where I see the big sort of challenge we have to have the biomass available, and we have to have the technologies converted from the fossil technologies into the biomass possibilities. And so the woody-based biomass will not be available for the chemical industry for 10, 15 years, because, for example, advanced ethanol or advanced sugars, they will go into the biofuels because we have the mandates. So the prices are much higher, and there we know we can secure the markets. So we have to have the ability to continue with the biomass that is existing in the market already. We have to have a level playing field. There are niches, like I said, where they actually will pay the surcharge, pay the extra, because most of the products will be more expensive. We need to compete with the imports or have the same demand on them. The market pulls again, then demand like the biofuels. We could say biofuels is a huge success. I mean, the advanced ethanol, for example, is going into the, to jet fuel, to marine fuel. The lignin will go to marine fuels. And investment can come when we have secured the market and competitiveness. So policy predictability. I mean, we are discussing the feedstocks and if they are sustainable or not. We need to know that they are sustainable and will be regarded sustainable the next 15 to 20 years if we make these huge investments. And if we do, then we will see the products we have in the picture, which actually some of them are already produced by Borregaard or what is included. I mean, we can turn most of what we are using, most of consumption into bio-based and forest-based for sure. Thank you.
Excellent. Thank you also, Ylva, for these explanations. I would say all four of you have, in a very good way, pointed out the opportunities. Thank you. This is an important starting point for our conversations, but you have also, of course, highlighted some of the challenges, and there are various issues to be addressed, but it's not only the inspirational products which you have presented, but it's also the processes and the governance of the entire value chain that need to have attentions. The general pattern seems to be a strong confidence, however, on the increasing demand for bio-based products for the substitution of fossil-based ones and the respective market pull. With this in mind, let's now move to the next round of discussions, and let's look at the issue of the co-creation of the pathways for the green, digital, and more resilient transition in some key industrial ecosystems outlined in the EU Industrial Strategy update. With your current products and experiences on interactive value chains in the forest-based industries, or the forest-based industries will be, from our point of view, really an exceptional position to offer a lot for the transition pathways in the construction sector, textiles, mobility, and energy-intensive industries. I would therefore, in the next round, ask you to speak on the challenges of the new partnerships and alliances in this new context, and how do you plan to respond and resolve some of them? Are there any missing links in your value chains, and how could we facilitate the uptake of your bio-based products, which you have mentioned, and how could we facilitate the shifts away from fossil-based ones, or partly at least, as in timber on top win-win examples shows. Also, I know that all of your products will be necessary to reach the transition pathways. Let's focus on the strongest inputs from each sector. So Sylvia and Clive, could you maybe first start out to share your perspectives on the one on construction, please, I think let's deepen that conversation first, and then I'll ask Anna and Ilva to come in on packaging and mobility. Sylvia, maybe first.
Okay, thank you. There is no doubt that, as I mentioned before, the wood industry have a key role in decarbonizing the construction sector. You have seen the recent development of CLT, the use also of a prefabricated wood solution to create a building environment much faster. But there is a point that it was touched already by Clive, and unfortunately I need to insist on, that has nothing to do with digital solution or new technology solution, although are also important. The wood sector cannot replace with any other material its primary raw material, that is wood. So when I look at the challenge of the future, then I'm afraid that the challenges are related to raw material supply. And the fact that although wood is the only European, one of the few European raw material that you have available here on the continent, we actually do not have a strategy on sustainable wood mobilization. So this is a very, very important point. And why I'm saying this, because if you do not know, if you are a wood industry and you do not know what it will be the raw material supply for the future, then you do not make an investment. So you do not make investment in technology, you do not make an investment in new solution, new application, you simply cannot. So this is for us is the biggest challenge for the future. And this is where we see that we should create a new alliance. So with the research centers, foreseeing what are the conditions under which we can utilize the forest, with the technology development, how can we mobilize raw material from the forest, but also R&D when it comes a new application of wood species that so far are not utilized. With this condition, we can play a key role in decarbonizing the construction sector. While we decarbonize the construction sector, we produce residues that can be utilized by our colleague of the wood-based panel industry, the paper or the chemicals product, in further contribute to the decarbonization of other sectors.
Excellent, Sylvia, thank you very much. I wish I would not be a moderator, but a discussant, and I could come into the discussion. But let me ask Clive to come in. I'm sure you have clear views on this as well. Please, Clive.
Yeah, thank you. Sorry. Yeah, I mean, let's say from the start, we are already a big alliance. The woodworking industries is a very well-functioning alliance, and I think that's something to be proud of. Round wood is cut for a sawn log. The byproduct of that ends up in a particle board, and then you have recovered wood at the end of the chain. So I think we do need new alliances, but let's pause for a minute to say this is one extremely efficient functioning one at the moment, and that's something to be celebrated. When you talk about new alliances, especially for construction, New European Bauhaus stands out. It's a fantastic project. We've created with our colleagues Wood for Bauhaus. We want to be at the forefront of that. We've already held a conference. We had 1,000 people join. There's great interest out there to do different things, and wood is something different. It's new. It's exciting. I mean, it's age old, but it's also new. And that we could get 1,000 people more onto a conference, I think says a lot for the interest that we have in that. So I think it's building, and we thank the Bauhaus project for that, because I think it's forcing us to open our doors to perhaps non-traditional partners, architects who we didn't previously speak to, building companies, specifiers. I think that's only to be praised. If we want to do a win-win, and this goes to a little bit what Sylvia said, we need to generate more secondary raw material. What I can't bear is landfill. I can't bear burning of wood when it could otherwise be used for material. So when we talk about what can we do better, I'd love us to see, there's a terrific Italian model where recycling is collected and redistributed to in our case, panelboard factories that can use it. It's a really well-functioning alliance between a waste collector, a municipality, and industry. And it ends up in your and my shelving and kitchen. I think it's fantastic. So that's the win-win I'd like us to think about. How can we grow that pool of secondary raw materials so that it can be used again, and we can protect the very, very precious resource, which is our forests and the timber from that. Thank you.
Thank you very much, Clive. As expected, you mentioned also very, very good links. Thanks for having mentioned the new European Bauhaus initiative. I think indeed the role of the wood-based industries is and their potential to make a positive contribution to that initiative, which is a bottom-up initiative, is significant. And also thank you for basically also addressing one of the current concerns Sylvia had flagged. Raw material sources need to be secured, but increasing the circularity in the entire system certainly is one very important step to also secure that in Europe we have better and secure supplies of the raw materials. Let me now ask Anna and Ilva maybe to come in on a couple of other examples. I think we talked about packaging and possibly also mobility. So Anna, maybe you first and then Ilva.
Okay, so when you say packaging, Peter, and I'm also ready to talk about textiles, but maybe for packaging, I would like to highlight a very the importance of alliances by giving you a very essential alliance as an example, and that is Forever Green. It's a cross-industry alliance that fosters synergies amongst companies promoting low carbon and circular fiber-based packaging. It brings together the entire value chain. That also includes the brand owners, and it enables cooperation with a comprehensive outlook on fiber packaging life cycle. So the overall aim of Forever Green is to raise the overall recycling rate of fiber-based packaging to 90% by 2030. So before we said 74% for paper and board, but now if we link hands with our value chain, we go up to 90%. And for that, we have mobilized 500 experts from all these companies to tackle these issues and move innovation forward. So that's a key example of why alliances are so essential. But then I want to come back to what Clive mentioned, that the same thing goes for textiles. None of this is possible without creating value chains, from the sourcing of raw material that comes from sawmill chips, plywood chips, and Synergy with wood construction products. So we are nothing without our partners in the forest-based industries. We are nothing without them. Otherwise, we cannot go any further. And textiles are a really tough market to break into because a very small fraction is made out of man-made cellulosic fibers. The dominating fibers are synthetics, then cotton. And the volumes of synthetic production is expected to even increase in 2030. They are cheap to make, especially outside the EU, and they have properties sometimes hard to replace by natural fibers, such as elasticity, especially in the case for polyamide and polyester. So in the case of natural fibers, we have cotton to compete with, despite the environmental issues that were also highlighted in Mrs. Callow's presentation earlier. That's pesticides, water use, and so on. But still, cotton production will increase in 2030. The other thing is that was not mentioned before is that the consumers don't know they often don't know that wood-based fibers are even used to produce textiles. Some technologies for producing textiles, such as viscose, is over 100 years old, but they don't even know that it is produced in the EU, that it's found on the shelves. And also the other challenge is also, how will you recycle mixed fibers? You need a separate collection and sorting system. Textile strategy is kind of helping with that, and the right investments in infrastructure. And it's also the question of doing a thorough research and explaining it to the consumer in simple language on the end of life of the effects of the fibers, so biodegradability, which will set them apart from fossil-based ones. And we have some studies, like a study from Lenzing on biodegradability of cellulosic fibers. But we need the communication to continue all the way to authorities and regulator to provide the right support for uptake of cellulose-based textiles, recycling of mixed textiles, and investments in separate collection and sorting. So I think we still have a long way to go. I still think we still need to also explain that if you have waste textiles, these have to be recuperated and re-injected into the circular economy. And that is something that is still lacking. Only 1% is now recycled. So these are some issues that I would like to give. So from packaging and also from textiles.
Great examples and associated with interesting challenges, textiles and packaging. In my own area, food and developing more sustainable food systems, packaging also play a very essential role. And I think all of you have also indicated that in what you have said, that of course innovation and research in all of these examples also play a very essential role. And Anna, you have also pointed out another important component, the consumers. We have to take them along and convince them that they are, yes, bio-based products which have also better properties, also from an overall holistic sustainability point of view. Ilva, let me invite you to come in with your example, please.
Yes, and then I will talk on the mobility and maybe energy sector. I mean, thanks to Renewable Energy Directive, I would say, where they're mandating advanced biofuels, the development and alliances between the chemical industry and the forest industry has started. I mean, that is to use well, what can I say, the cascading use, the chemicals going into circulation in the pulp mills, and there you have the lignin, and which then can be converted into marine fuels or jet fuel. We see this happening right now, but also using the sugar streams didn't end up as a fiber. Then the sugars can be fermented into also biojet and to ethanol, and they are cooperating and building together. This is a fantastic development, and I think lignin will play a big role here. But also this is, well, counterproductive, you could say. It will not end up as a feedstock for the chemical industry. On the energy sector, unfortunately, normally the plants are not situated together. The chemical industry needing a lot of energy and the pulp mills having access to energy. In the past it was, I'm representing actually a factory in North Sweden where we were part of the pulp mill, now separated. So we used ethanol, and we still use ethanol for chemical production and energy, so we're integrated. And that's the way we need to do in the future, but we can't move the big facilities. So there I don't have a solution, but I think we will see more and more small chemical factories being situated close to the pulp mills, even if they are not owning all of them themselves. But we will see more of a cooperation from newly developed chemicals whatsoever together with the forest industry. So these alliances will grow for the future.
Thank you very much, Ilva. That is also promising, and indeed also, yeah, expectations are high, but I think we already see quite a lot of very, very positive solutions in the mobility sector. And again, I think it's an area which is very research and innovation intensive. Again, I think an important point will be to use the precious raw material in the most efficient and more efficient way. Now, we would have other topics to discuss, but it seems to me that we are running out of time, and therefore I also would like to ask you to come to the last round and just give us one take-home message also from these discussions. Maybe let's start again with Sylvia, and then Anna, Ilva, and thereby ladies first, and then Clive as a closing. So Sylvia, please.
Okay, so if I really have to choose just one take-home message, then I think that the forest-based bioeconomy challenges is correlated to the aspect associated with sustainability and how to minimize environmental pressure. This is linked to how to provide accurate and correct information also to the final consumer, while at the same time, because we are developing standards, we are developing so many policy and information, how can we reduce bureaucracy for the SMEs and prior any legislation, because the forest-based industry, it's very much composed of a micro enterprise. We need an impact assessment of what might be the consequences of that legislation in terms of cost on the small enterprise. Thank you.
Thank you, Sylvia, for these points. Anna, please come in.
Well, we are nothing without our alliances. So, because we are facing challenges that are bigger than us. And especially, we should know that these bio-based products and bio-based solutions already exist. So consumers need to be empowered to pick them. This will have an immediate impact to tackle climate change. This is why we will need to achieve bio-disruption all over Europe.
Excellent. Bio-disruption, I like that, that wording. Over to Ilva, please.
Thank you very much. And from my side, it's policy stability and predictability. So we know it for a long time, but also the calculation of a footprint, because it's not taking into advantage if you have a bio feedstock, is just end of life, but not in the beginning. This has to be changed, because we are meeting people saying, or companies saying, you're not better than the fossils. But we are. This is a calculation method, the PEF method. I see Sylvia is also having the same situation. And then the market pull, something helping, because many of these products will be more expensive, and there is a market for sure, certain segments, but maybe people in general is not prepared to pay extra for all of the products. So we have to do something on this side, because investment we can solve if we know the market, we have stability, we have a profitable production. Thank you.
Thank you very much. That implies that we also need to communicate the good things the forest-based industries are doing, and sell that story better. Clive, please, last word for you.
Thanks, Peter. So my key takeaway is a really upbeat one. Post-COVID, everyone wants to live better. Post-natural disasters, we need to achieve net zero. Great news, we have the solution. For once, we have the solution to hand. The bio-based industries can do that. Nature-based materials like wood-based panels, they're ready and waiting. They're climate smart, resource efficient, and let's not forget, and apologies to those outside Europe listening to this call, Europe is the global champion in this area. So we have products that are designed in Europe, sourced in Europe, made in Europe. Let's use them. Thank you.
Thank you for that very positive message. I think that has been well understood, that the forest-based industries can play an important role in the green transition of many industrial sectors. I think that was a very clear message that disruptive solutions from the circular and woody biomass sectors have a lot of opportunities. And I think all of you have also explained that we need better products, better governance, better alliances, better policies, predictability. But I think if we continue to engage with each other, if we continue to also talk with the consumers, the citizens, also about the advantages of these products, I think they indeed can make the positive contributions we have outlined here this afternoon. Thank you very much to all of the participants and also to the participants in this session. Thank you for having stayed with us this afternoon. It would have been very nice if that had been a physical event, and if we could now meet in the corridors and continue the important discussions in bilateral conversations. If we could go out for an after-conference drink, would be very nice. I hope we'll be able to do so next year. Thank you all very much. I will therefore close this event with the wish that next year COVID-19 will be well tamed and we can all meet in a real setting again. Thank you very much for your great contributions and your efforts. It was an excellent closing round of discussion. Wishing all of you a very nice afternoon and a good evening wherever you are around the globe. Thank you for having listened in. Thank you for having participated in this event. Bye-bye.
Cheers. Thank you.
Thank you.
Bye.